Hi, my name is Donna Millette, and I will be going over carbonyl, carboxyl, and amino groups within this segment of this video. The carbonyl group is a functional group, which are groups of atoms within a molecule that are responsible for the characteristic reactions and behaviors of that molecule. The carbonyl group consists of an oxygen atom sharing a double bond with a carbon atom, and the carbon atom sharing single bonds with other atoms which vary depending upon what the molecule is bound to. The carbonyl group shows up in two forms, ketones and aldehydes. A carbonyl group is a ketone if it is inside a molecule's carbon skeleton, but it is an aldehyde if it's outside a molecule's carbon skeleton. Now this segment is a little bit of practice to determine if the class can now distinguish ketones and aldehydes. If a carbonyl group is in between two carbons within a molecule, it can be called a ketone. If a carbonyl group is to the left of two carbon atoms within a molecule, but there are no more carbon atoms on any other side of it, it can be called an aldehyde. An example of a ketone is acetone, which consists of a carbonyl group in between two carbon atoms through single bonds, which shares single bonds with three hydrogen atoms, each. An example of an aldehyde would be propanol, which consists of a carbonyl group sharing single bonds with a hydrogen atom, and another carbon atom, which shares single bonds with another carbon atom to the left of it and two hydrogen atoms. The carbon atom on the far left of this molecule shares single bonds with three hydrogen atoms. The carbonyl groups influence the role of a molecule by increasing its polarity and reactivity, along with some other characteristics, like the fact that a lot of molecules with a carbonyl group in it seem to be somewhat volatile to human senses, like releasing strong odors, for example. Now we will be going over carboxyl groups within this video. The carboxyl group is another functional group that exists within molecules that contain an oxygen atom sharing a double bond with a carbon atom, and the carbon atom shares a single bond with another oxygen atom, and this molecule shares a single bond with a hydrogen atom at some point, typically through one of the oxygen atoms. This functional group shares a single bond with another molecule through the carbon atom at the center of it. A carboxyl group is often referred to as carboxylic acid, aka organic acid, and an example of a carboxyl group would be hexanoic acid, which consists of two carbonyl groups to the left and right ends of it, and a center consisting of four carbon atoms, all sharing single bonds, each with two hydrogen atoms on either side of it through single bonds. This segment is some more practice to test if the class has paid attention during this portion of the video. With that said, an organic acid can also be called carboxylic acid. Carboxyl groups influence the role of a molecule by often being highly polar and reactive, though these characteristics are also influenced by size, and are often referred to as acids due to their tendency of releasing hydrogen ions into a solution, which lowers the solution's pH. Now we will be going over amino groups. An amino group is a functional group comprised of a nitrogen atom sharing two single bonds with two hydrogen atoms, with the third hydrogen atom sharing a single bond with another atom somewhere in the molecule, usually the nitrogen atom. This functional group is bonded to other molecules through a single bond from the nitrogen atom, and the compound name of these functional groups are amines. An example of an amine is glycerine, which is comprised of an amino group on the far right of it, which shares a single bond with a carbon atom, which is bonded to another carbon atom and two hydrogen atoms through single bonds, while the other carbon atom on the far left of this molecule shares a double bond with an oxygen atom and a single bond with an oxygen atom that is combined with a hydrogen atom. The amino group influences whatever molecule is bonded to by increasing the polarity and reactivity of the molecule, along with enabling the molecule to readily form hydrogen bonds of water and other polar molecules. Amino groups are also influence the characteristics of whatever molecule they're bonded to, often by binding to hydrogen ions in a solution, which raises the pH and causes it to become basic. Now answer this question if you can. In this portion of the video, when I was describing amino groups, I listed an example of an amine. What is it called? The correct answer to this question is glycerine.
Okay, welcome to Biology 101. My name is Braden Townsend. I will be your guide into the wonderful world of biology. Now, Anna and Danielle have already put their videos on here, and that's fine. That's fine. I'm doing this. This is my I'm the last person doing this. I got my lab coat on. Happy. Now, the lab coat, but however, that's not the most important part of this. The most important part of this is the fact that I'm going to be presenting this to you, and it's going to be fun, and we're going to have fun. Now, I need you to tell me something. Do you guys know what this is? Can you see this? Probably not. I'm going to make a new one. This is the first group up is the sulfohydryl group. The sulfohydryl group is a functional group which groups of atoms within a molecule that are responsible for the characteristic reactions and behavior of the molecule. The sulfohydryl group consists of a sulfur atom and a hydrogen atom ionically bonded, and it's bonded to other molecules through a single bond. The compound names of a sulfohydryl group is thoi. An example of a molecule that is a sulfohydryl group is cytosine, which is comprised of a hydrogen and an oxygen atom combined with a carbon and another hydrogen oxygen combined to a carbon, oxygen, hydrogen, nitrogen, hydrogen, and hydrogen. This, I just broke my chalk. Oh well. This is a sulfohydryl group. Can you see this? Camera, zoom in. Come on, camera, zoom in. This is a sulfohydryl group. Thank you, camera, for zooming in. Let's move this over just a little bit. Down. Over. Sorry about my camera. It's being weird. Okay, now the next thing I'm about to say is going to be a bit of a shocker. Cytosine or sulfohydryl groups are found the thoi molecule, thoi compound. An example of something that a sulfohydryl group is found in is thoi, which I already said. But the thoi compound is something that's found in onions and skunk spray. Now that's very, very, very nasty. Like that vapor that happens that you get when you cut a fresh onion, makes you cry. That's thoi, which is a sulfohydryl group. The skunk spray contains thoi, which is a sulfohydryl group. There's a sulfohydryl molecule, which makes it stink. The sulfur compounds. Now the sulfohydryl group. The cytosine consists of 7 hydrogens, 3 carbons, and 3 oxygens, and 1 nitrogen. Now, it also consists of a sulfur atom somewhere in there. I'm not sure where exactly, but I know it's in there. The sulfohydryl group is bonded, influences whatever molecule it's bonded to by enabling the molecule to become more reactive with oxygen as the molecule is easily oxidized. Now, I have a question for you to answer. What's the compound name of a sulfohydryl group? The answer is thoil. I named this earlier. Like I said, it's what's found in skunk spray and onions. Nasty, nasty stuff. Now the next thing is a methyl group. The methyl group is a functional group comprised of a carbon atom ionically bonded with 3 hydrogen atoms, and this functional group is bonded to other molecules through a single bond. Compound name of methyl groups is a methylated compound. Methyl groups are, example of this is 5-methylcytosine, which is which is this molecule right here. Can you see this? Let the camera move a bit. Here, let me get my camera right up here so I can show you. 5-methyl cytosine is that molecule right there. Hydrogen, 3 hydrogen, 3, 4, 5 hydrogen, 3 nitrogen, and 1 oxygen. 6 hydrogen, sorry, and 1 oxygen. This is 5-methyl cytosine. 5-methyl cytosine is a DNA suppressor. It will suppress foreign DNA so as to keep it from going, keep it from reproducing, which can end up being very, very bad. Let me just adjust this a bit. Thank you. Okay. If foreign DNA produces, it can be very, very, very bad. Viruses and bacteria are examples of foreign DNA that reproduce. When they reproduce, how can I put this? It's bad. It's very, very bad. People die because of this. But that's where 5-methyl cytosine comes in. It will repress DNA. Say this is the DNA of a virus that's gotten into a cell. Here's the cell. When 5-methyl cytosine is activated within the cell, the virus, although the virus is still getting into the cell, it's very, very slowly being destroyed by the 5-methyl. And then eventually, it's gone. So, in essence, it can be very bad if a virus was to be able to reproduce inside your body. Now, a methyl group within a molecule influences that molecule by making the molecule nonpolar, and thus hydrophobic, so that it does not readily bond or react with water molecules. Now, I have one last question for you. I listed an example of a molecule with a methyl group in it. The answer is in 5 seconds. See you there. Back? Did you get it? The answer is 5-methyl cytosine. This molecule. Now that molecule is, like I said, DNA suppressor. Now, I'm going to go over this again. This molecule is thoyl. Or, sorry, not thoyl. That's an example of a molecule with it. This molecule is... what is it? It's in here somewhere. The example of this one is cytosine. Sorry, this is cytosine. Not cytosine, cysteine. With 7 hydrogens, 3 oxygens, 3 carbons, and 1 nitrogen. 5-methyl cytosine has 6 hydrogens, 1 carbon, 1 oxygen, 2 nitrogens. And in the end, wrapping this all up, make sure that you keep up with all of this. Hope you're taking notes. There'll be a short test at the end of class. I know I'm a jerk. Now, this was lovely, and I will see all of you guys next time. Bye.